Spotifyers, click or tap the banner to listen to Happy Holidays. Spread some cheer with this list of new and old seasonal favorites. Brought to you by our friends at Lexus. Experience amazing.
Holiday movie season is right around the corner, and we have the hottest soundtracks one click away, including music from the new films Bright, The Greatest Showman, Mudbound, and more. Listen now.
Still looking for that perfect gift?
What's up with these advertisements? It won't even let me mute it. Alright.
And did we mention there's free shipping on everything? Call 800 by Dell. That's 800 by Dell.
Alright, so we got 1 minute. This is gonna be a pretty hopefully I could do this well. Coming in kind of cold on this tutorial. Just got home from work. Have a little bit of time, so see what happens. Alrighty. Alright, we're here. Get rid of this window. How do I get rid of this window? Go away. Alrighty. So if my music's too loud or anything, please let me know. Today, we're going to be continuing a second part of the multiplayer networking series. This is a quite advanced series, so if you don't know about buffers and data types and I don't know, data structures and things like that, I've made a ton of videos on them, done a lot of live streams, done videos. I can link those for you guys, but even if you have, that's totally fine too. What I mean is, if you don't know about that stuff, you could probably still watch this and get something out of it, so stick around. But let's go ahead and see where we stopped on the last stream. So on the last stream, we set up basic, I guess I'll go ahead and play it. Let's see. And by the way, you could get the starter project from the description in the last stream if you wanted to follow along there. And this will be uploaded. So let me go ahead and start this, and I'm actually going to open up another instance of it. Where are we at? Networking. I think this one's it. So again, if you haven't been following, we're using UDP. We're not using a TCP system. Generally, TCP isn't used for real-time games. That protocol is kind of, it's a bit slower. There are some real-time games that have managed to do it, but in general, UDP is usually used and preferred, and TCP behavior is implemented in UDP or with UDP. So that's what we're going to be doing. We're going to be doing advanced concepts such as server reconciliation, client-side prediction, client management, all the advanced stuff. So that's where we're going. So let me go ahead and open up my second instance here. Since these are actually two separate programs to Logic, even though we're combining the code into one GameMaker project, they are two separate, their code is different, okay? They don't talk to each other through the code necessarily. They talk to each other through sending packets over the network. So right now we basically just have a super simple system. We set up a basic packet sending. So if I set up a server initialized, and the client joins in, says new connection attempt, but we haven't actually handled the connection yet. We received the packet, which is all good, but we have to take some steps. Since we're not using TCP, then we don't have a sense of connection. So we have to emulate that sense of connection through UDP packet sending. So when we send a packet over UDP, we don't know if it gets received by the server, okay? So we could sit there after we send it and wait forever, but chances are maybe that packet got lost somewhere in the internet and went to some dead end and did not get retrieved by the server. Okay, so what needs to happen is we need to kind of send at an interval that we set until we get a response back from the server, okay? And then even after we get that response back, then we're going to start sending something that you can call a ping, or I like to call a heartbeat. And this is how we manage our connection. So we're going to have this, even after we get our connection, we're going to have this stream of data that we're going to send at a certain interval. And this is how the server is going to know that we're still connected. And the server has a timeout amount. We'll have a timeout amount, or a certain time that we specify. And it says, hey, if I haven't received data from this client within the last minute or so, then he's probably not connected anymore. And then the server can safely get rid of that client's data, okay, and open up a new slot for a new player. So that's where we're headed. So let's go ahead and see where we're going next. So in this video, we're going to be handling the connections. What do I mean by that? Oh, come on, GameMaker, work with me. So as you see, I have my server and my client, and we need to actually store in our server when a client connects. We need to, again, handle sending him some information back, such as a client ID. So let's go ahead and first do that. I need to talk about it a bit more, I feel like, but let me open up some things, and then I got to stare at some code to really get into it, you know what I mean? So let me go ahead and maximize this. This is our create event of our server. We have our async. Async's where we receive data, and we're going to need to send something back on this message received. Okay, so right now we just have a message type, and we have an enumeration that is called a message type. And our packet contains the message type. So when we receive a message type, then we read from our packet, and we see that it's a connection request. And since we know it's a connection request, we know what to do with the rest of the data. In this case, we're just adding a log message, which is that thing you see at the top left, and that's all we're doing. So what we actually need to do here is when we receive this connection request, we need to pull some kind of ID out of a hat or something to assign, some client ID that we can send back to the client, actually, which I've had some iffiness about recently. You could actually, they don't need to know their client ID necessarily, but I think it's useful, and I'm trying to think of a reason why they need it. But yeah, I guess they need it to know how to manage their own side. So let's go with that, because that's how I built my original project, and I've just had kind of different ideas of different ways to do things. So, but I'm going to stick with what I know, and that's what I know for now. So we receive a connection attempt. Let's actually go to our client and see what happens when we send the connection attempt. So we have a client and a client pawn over here, and they're two different things. And this is our server. Actually, sorry, I needed to go to my client info. I'll explain the client pawn later. We need to go to our player client, actually our connection handler. This is in our client hierarchy of our project, okay? You can notice, if you're just now joining, that we have a server and a client, basically folders. That's because these are basically two applications. They're two different applications. They don't talk to each other through code. They talk to each other over the network. So I'm going to try to keep everything minimized that isn't in the current application. So we're going to be messing with our connection handler in our client, which is what handles all the networking, okay? So our connection handler on create, basically when we click the client button and it takes us to our client's room, we have a connection handler that gets created. And on create, this is when the connection attempt happens. Right now we're hard coding the IP that we're connecting to, which is 127.0.0.1, which is our loopback address. Basically, this doesn't go outside your network. It just basically comes back to your computer. I don't even think, yeah, it doesn't even go outside your computer. This just is how you can kind of talk to your own computer over some internet protocol, okay? Which is UDP in this case. Okay, so you can see on create, we send a connection request, okay? I just gotta minimize it. Come on. Boom, okay. So this is our create event. And you can see we send a connection request. And this is a really basic buffer. We're packing one piece of data into it, which is a buffer U8, which is an 8-bit unsigned integer. And again, I went over data types in one of my previous live streams really thoroughly and showed you how you can use these. So this is an 8-bit signed integer. You can see what it looks like here. That's 1 byte, which is 8 bits. And all we did was pack in the message type connection request, which we can actually see is just the number 0, which obviously is an unsigned integer. It doesn't need to have a negative in front of it, so it's unsigned. Okay, so that's what we packed into our packet, and we sent over the network, and this is what our network received. So after we send this, we need to start handling a connection. We need to be waiting for a response from the server, okay? So the first thing that we need to do is create a new variable that we can call, let me get above all this, connected. And we'll set this to false by default, right? Okay, that's because we are not connected, obviously. And next, we need to, let me fix my mic. Next, we need to be polling to see when we need to be checking that connection. So we're actually going to use an alarm for this. So after we send this, let's go ahead and set our alarm. So we send our packet, and we set alarm, we'll just call it alarm 0 for now. And this is going to be like our wait time, okay? So we'll set this to, we'll send a packet every, let's say 500 milliseconds. This isn't milliseconds, that's 500 steps. So 60 times a second is not what we want. So what we're going to do is do 30 times would be twice a second. Let's do 15 times. Let's do 30 times, yeah. Twice a second, that seems reasonable. So you could do your room speed divided by 2 if you wanted twice a second. Actually, is my room speed at 60? We'll just do 30. It'll be fine. So every second, if it has to be, is just fine. Okay, so let's go to our client's alarm. So let's go to alarm 0. And this is where we see if we are connected again, okay? So remember, if we do receive a response back from the server, it's actually going to be in an event called networking asynchronous right here. So if you go to asynchronous, it's under networking. So when we do receive this message, I'll go ahead and say receive messages. Okay, when we do receive a message saying connection success, we need to update connected variable. Okay, so when we do receive that message, we're simply going to say connected equals true. And I'll explain this. This isn't all we're doing here. I'm just giving you an illustration of what's going to happen. So in our alarm, we can say check for response. Say connection response. Okay. And here we could say if connected. Really all we have to do is say if not connected. If we still aren't connected, then we want to send that message out again, okay? So we're gonna send this message again. So let's go ahead and bring all this out to a new script, okay? So let's create a script, and this is gonna be under our client. So I'm gonna label it CL, prefix it. And this is gonna be send connection attempt, okay? Attempt. Let me bring this out for you guys a bit. Send connection attempt. Which is just fine. I'm gonna, ooh, that's not what I wanted. Do we need the alarm? Yes, we still need that alarm. Okay. So actually, no, let's not include the alarm in this script. Okay. Socket. Okay, cool. There we go. So I'm gonna add a description here like I try to always do. Description. Send connection packet. Well, actually this is connection attempt. Packet to server, okay? And that's all this does. And that's all we're gonna do. So we're gonna cut this out and we're gonna say CL, send connection attempts. And then we're setting our alarm for polling. Set connection, polling, alarm. Let's go to our workspace. And again, if we're not connected yet, by the time this alarm comes around, we're simply going to send another packet. and we are going to reset our alarm. And actually, let's bring this out to a new variable. Let's call it connect attempt wait time. That's what we'll name our variable in our create event. So let's go back to the create event and let's set that up here. Connect attempt wait time, we'll say is 30 steps. Okay. Go back to our workspace. And we have our connect attempt wait time. That should work. So this is going to keep polling until our connected variable becomes true. Okay. So it's going to resend the connection packet to our server, and then it's going to reset this alarm. So it's going to keep doing this. Okay. And then that's really all we need to do. Because when connected becomes true, the alarm's not going to be reset, and this alarm's going to stop working. Okay. Awesome. So let's go and send a message from our server to our client saying, hey, we got your connection attempt message. So we're going to go to the server. And let's do server. Okay. Exit all these out. And we have our create event. Or no, this is our reception event. Okay. So our message type is now connection request. So what we're going to do here is send client a connection confirmed packet. Okay, so that's our next goal. Send client a connection confirmed packet. So how do we do this? Well, let's make a little script. Let's call it SV. Send packet connection confirmed. Yep, and it's a long name for a pack or for a script, but that's how I do it. I keep long descriptive names. So let's create a new script. I'm going to add it here. Let's make sure I can't see this. There we go. Connection confirmed. Awesome. So how do we create this packet? Well, it's pretty simple. First, we're going to create a new message type. So I'm going to go to my shared folder for my scripts, and this is where both our server and our client can use these values established in here. And we're going to say, this is actually going to be number 1. We're going to say connection confirmed equals 1. And we're going to have a comma. Position update, I'm going to move to 2. We haven't implemented that yet. Okay. This is just an enumeration. These are basically just going to be constants at this point. So we have a connection confirmed packet that we can use now, our message type. Awesome. So how do we do this? First, we need to create a buffer, and we're going to say send buffer, and we'll just use var for this. We'll say var send buffer equals buffer create, and we have to give it a size. Okay, so what's the size we're going to give it? Well, this is how many bytes we need in our buffer, and our connection packet's going to take 1 byte. Our message type is going to take 1 byte. And then we're going to have to send a second byte, and this is actually going to be the client's ID. So we're going to pick a new client ID for this client, and we're going to send them that as well. So our size for our buffer is going to be 2. And our buffer type is going to be buffer fixed. This is basically saying this is a fixed size of 2 bytes. You can use grow, which means if you keep adding more data, the size of the buffer is going to keep growing, but I like to have complete control over everything. So I'm using 2 bytes, and I'm fixing it at that 2 bytes. Okay. And the alignment is going to be 1. And honestly, the alignment is something I'm a bit iffy about. I've tried a lot of different things, and I've had things work and things break, and 1 just seems to work. There's some specification in the documentation about it, but I haven't had much I haven't had too many different results. Basically, I think it's after you do a write or a read, it's how many bytes to skip. I think that's what the offset is. But we're not skipping a byte, or how many bytes to move from the current pointer that you're at. It's basically what it is, I believe. So now we have our buffer created. We need to seek the pointer position. So if you watched my previous videos, you know what I mean by a pointer position. This is basically which byte are we pointing at to write into, okay? So we're going to seek the first byte because that's where we want to start our writing operation for our buffer. So we're going to say buffer seek and we're going to say we need to move our pointer in our send buffer. That's the buffer we're referencing. And the base is going to be buffer seek start, which is going to point at the first position in our buffer. And the offset is going to be 0 because we don't want to start at the first. So you could actually do buffer seek start and then offset 1. You could actually start at the second position in our buffer. But we want to start at the first position, which is going to be offset of 0. Awesome. Now we need to write some data into our buffer. So we do that by using the function buffer write. And we say we're going to write into the send buffer. And then we are going to write a type. This is a data type, a GameMaker specified data type. And hopefully you watched my previous videos and you know what these data types are. And if not, I'll try to explain. We're going to use a buffer of an unsigned 8-bit integer. What this is 8 bits, so it's a 1-byte integer. You can represent up to a value of 255, 256. Shoot, I always get those mixed up. I think, yeah, 256, I believe. And it's going to be unsigned, which means you can't use negatives. If you used a negative, then you wouldn't be able to use up to 255, the value 255, where you'd get an overflow. Anyway, enough of that. It's a buffer u8, and the value we're giving it is message type. This is how we're going to prefix all of our packets, is with the message type. And we're going to send a connection request. Or actually, connection confirmed. Sorry, not request. We already sent that one. So now we're confirming the client's connection. And the second piece of data we're going to write, since we have another byte to work with, is going to be the client's ID. So send buffer. And we actually need to write a way to manage client IDs now, which we will do using a stack. But we're going to create a function called retrieve new client ID. Okay? And this is going to be a script we're going to create that's actually going to retrieve a value to store inside of our buffer. Okay? And actually we have to give it a type, which is going to be buffer u8 again, 8-bit integer. So we can have client ID from 0 to 256, and that's the maximum amount of clients we can have using this system. So let's go ahead and start managing our client IDs. 0 to 255, TMC tells me. I believe that. Sounds right. So for an unsigned 8-bit integer, you can have value up to 255 because it's 0 inclusive. That makes sense. 256 values because 0 is inclusive. Okay. Let's go to our server and retrieve a new client ID. First, we have to create some kind of client ID system. How we're going to do this is using a stack, okay? Oh, okay, so now we're in our create event, so we have to initialize our stack. Why are we going to use a stack? Well, we're going to use a stack because a stack is a first in, last out. You could use a queue as well, probably. But a stack means we're going to stack a bunch of numbers, available numbers, so probably 0 to your max clients. So imagine you have a max client of 16, and you have, so that means you can have 16 players in your game. And you have, now imagine you have 16 plates, okay? That's what we're going to imagine is plates, because you're going to have a stack of plates. And each of these plates has a value, an ID, okay? So you have the plate at the bottom. We could start stacking. We could start that with the largest number. So you have plate at the bottom being 15, and then 14, 13, 12, 11, 10, 9, 8, 7, all the way to 0. So the top plate could be 0. And now to get to the bottom plate, you first have to keep taking off, starting from the top, you have to keep taking off plates. So when we say we want a new value to send to our client from our stack, we just pick the top piece off. So number 0 is gone, send that to the client. Well, now we have number 1, send that to the client. Another client connects, number 2, number 3, all the way down to 15. Now the stack is out of values. But let's say a client disconnects. Well, we just add that client's ID back to the stack, right? So once again, we can have stacks. So we just pull and basically we push and pull things off. Push and pop is what they call it. So let's see how to implement that in GameMaker. Well, it's pretty easy. I'm going to go ahead and write some comment here. We're going to say initialize client ID stack, okay? And we simply do ds stack create, and we have to assign this to some referenced variable, and we're going to assign this to be, let's say, client IDs, okay? Awesome. So we have a stack now. Next, we need to add some values. And let's go ahead and add our max clients. We're going to put that up here, max clients. And like I said, I'm going to set that at 16. That seems reasonable. And next, we need to add all these 16 values to our stack. So how do we do that? Well, we just use a for loop. We can simply say, unless there's some DS stack function that I don't know about, empty pop push read size top right. Yeah, I don't know. I don't think there's a cool function to do this. So we're going to use for. And once again, if we just go from 0 to 16 and add to the stack, then to retrieve the 0, we'll have to start at 16. So 16 would be on the top of our stack. And that's the one that's the only value we could get to, because using a stack, we can only grab the top value at a time, okay? We can't go get a middle value or we'd break all the plates, right? So we are going to instead starting at 0 and stacking all the other plates on top and having the top value be 16. We're going to start at 16 and stack in descending order all the values so we can start with grabbing client 0. So we're going to say for var I, and this is going to be started our max clients. Okay, actually we need to do max clients minus 1. So we're going to start at 15 because 0 is going to be inclusive. And we're going to say as long as I is greater than 0, that's what we want, right? Yep, I is greater than 0. We're going to do I minus minus. Okay. And next we are, oh, sorry, I minus minus, yep. And that's what we're going to do. So next we're going to add these values, and the value that we're going to be adding is simply I to our stack. So we simply do ds stack push, and we have to give it the values to push. Doon, doon. 1 second. I got a nifty. Can you actually put in? Yeah, this is how I'm going to do it for now. I could look at that. TMC just sent me some info. You could, DS functions, you could pass all the numbers in one go. I would have to give them, yeah, let's do that. It's a bit simpler. I think we could do DS stack push. And we can give it an array, I believe. So some iteration since the value's down here. This may be an easier way to do it. I'm kind of going off the path here, but we could actually do, what's the stack we're pushing to? We're pushing to the, what do we name it? Oh, client IDs. Sorry, I lost track. Client IDs. Okay. And next we are going to, I think we could insert the actual array. So you could actually do something like this. You could do, no, we'll just have to count 1 to 16. I don't like this. We're going to go back to the for loop. I'm missing something, I think. But we're going to do it here. Client IDs. And then we're going to just simply add I. It's that easy. So we're pushing I onto our stack. Okay. And you don't even need these curly braces. So we got 2 lines. That's fine with me. Okay. So we have client IDs. We created a stack. And we're pushing on that stack using the value of I. Sweet. And now we have our stack of IDs. So we can simply create a new script. Remember, if we go back to our send packet connection confirmed, we need to retrieve a new client ID. So let's go ahead and make that. So this is under our server folder. So I'm going to create a script. I'm going to say SV. Oh crap, I just forgot what it was. Retrieve new client ID. SV. Retrieve new client ID. Awesome. So now we're just going to pull a value off the stack if one exists, okay? And if one doesn't exist, we're going to return, let's return -1 if one doesn't exist. And we can use this to deny the client's connection, saying, hey, we're already at max users. So we can simply do something like, give a description at first. We're going to say description, attempt to retrieve a, attempt to grab a client ID. If no spot is available, return -1. There we go. Easy. So let's implement this. all we have to do to grab that value off the stack is say ds stack pop. And we give the ID stack to pop from. We just simply say client IDs. And there you go. And this actually returns the value and removes it from the stack. So if we go to our help menu, pops the value from the top of the stack. This function will pop the top value off the stack, removing it from the stack and returning the value stored in the variable. So we don't even have to remove it explicitly because this function handles that for us. So we just need to save this. Actually, does this return something if no value is available? Pop value off stack, removing it from the stack, returning the value stored in the variable. What happens if you pop one? If it's not, then it pops the top two. Okay, I won't mess with it for now. I will say, I'll just say if ds stack empty client IDs. So we're going to check and see if the stack is empty. And we're going to say if not, if the ds stack is not empty, we're going to return this value. And we don't even have to say else. We'll just say return -1. So return is going to cancel the execution of the rest of the script. And so in this case, this would not get executed. But in the case that ds stack is empty, it's going to get down here and return us -1. Awesome. So actually, we need to retrieve this client ID before we do the rest of this buffer. Okay. So, yep, all we're going to do is say var new client ID equals retrieve new client ID. And we're going to say, we can keep this. Yep. Actually, let's do 2 different buffers here. We could actually split this out to 2 separate scripts, but we're going to keep it 1. So if the client ID is -1, then we don't want to do this. We don't want to send a connection confirmed, or we want to send a connection denied packet. So we're going to say if new client ID is greater than -1. Actually, we just say if it's not equal -1. That's just fine. Then we're going to execute this connection confirmed, because that means that we pulled a value off the top of our stack. Let me go ahead and move this up here. Send buffer. Then we'll use send buffer. Okay. And in any other case, we are going to send a connection declined or a connection denied. Very cool. Denied packet. Okay. And let's go ahead and fill out our buffer here. So let's send our client ID here. New client ID. And then in this case, we actually don't need to send a second piece of data. So we're just going to send the connection denied, and that's going to be it. So we need to change the size of our buffer to 1 in this case. Okay. So 2 different pieces of action. Let me go ahead and label this out. Client position available, and this is no available client positions. Awesome. So we just set up a sending the client some data back. So let's retrieve this data back using our client system. So we're going to jump over to our client. I'm going to close out the server. We're going to go to the connection handler in our client system. And let's attempt to receive some data now. And we're going to delete this because that's not what we need. And got to remember all the data here. Basically, when this async event happens, something becomes available to us called async load. Okay? This is a map that GameMaker supplies to us with some information, basically. So we can actually access some built-in things given to us in this event only. These are not available outside of this event, so you can't go to the create event and use this async load, or anywhere else and use this async load. This async load gets destroyed after this event's over. So we have to handle all of our connection stuff inside of this async networking event. So we can actually get the buffer that the server sent by using async load buffer. And what we're going to call this is the received buffer equals async load. Okay. And then we are going to simply parse the data inside this buffer. So instead of writing, we're going to be reading, okay? So this is basically the same as, this is the same as creating our buffer, kind of. We just created a new, well, we didn't create a new buffer, but now we have a buffer available to read and write to, but we're not going to write, we're just going to read. Simple. So to read from this buffer, using that data we found, we know that the first byte in our buffer is always going to be the message type, okay? So that's going to tell us what we need to do with the rest of the data inside of our buffer. So the first thing we need to do is buffer seek to move to the end of our, or move to the beginning of our buffer. That's where we want our pointer. That's where we want to start reading from. So where do we want to read from? We want to read from our received buffer, okay? And the base, we're going to say buffer seek start. So it's going to go to the start of a buffer with no offset. Awesome. So the first value we're going to read is our our packet type. So we're going to say var packet type. Let's say received packet type equals buffer read. And what buffer are we reading from? We're reading from the received buffer. Why is that so hard for me to say? Reading from the received buffer. And what is the value type that we expect to read? Well, if you remember, when we sent the buffer, when we were writing to it, we gave it a data type, and that data type was a buffer of U8, okay? And that's where we're going to tell GameMaker to expect to read. So it's going to go to the first position in our byte. So 1, 2, 3, 4, 5, 6, 7, 8. We have the first position in our byte. Actually, this is what it means. If you have 2 bytes, then buffer seek start will go here to the first position. Basically, this first character, that's the address it's moving to. And the offset is basically the offset to move. So should we start at this byte or this byte? Okay, so what happens is when we do buffer read and we say buffer U8, it's going to move 8 bits over, okay? It's going to read, starting here, 1, 2, 3, 4, 5, 6, 7, 8 bits over. So it grabs all these, and then the next thing it needs to know is how to interpret these 8 bits and what kind of value to turn it into. And that's what the unsigned means, okay? So it knows it's going to be an unsigned integer at this point. So it interprets these 8 bits as an unsigned integer. So for instance, this byte for an unsigned integer would be equivalent to the value 2, the decimal number 2, okay? And if you didn't watch my previous streams, then go back and watch them. I go over this in detail. Awesome. So we just read our received packet type. So next, we simply do a switch statement that we're going to be using, and we switch on our received packet type. And then we're going to use a case, and the first case is going to be message type, dot, and this is connection confirmed, okay? Awesome. I don't need this. I don't know why I did that. I don't like it. Okay. So we have our message type, connection confirmed. What do we need to do at this point? Well, we need to say, hey, we're connected. So we simply say connected equals true. Done. That's all we're doing right there. It's finished. Dunzos. And in the case of message type dot connection denied, which we haven't created yet, connection denied, we are going to say, well, we need to break out of that alarm. So what we're going to say is alarm 0 equals -1. I think that works. I don't know. Actually, normally you would move back to like your lobby room, right? Or do some other kind of action. But what we'll do is we'll just show a message here saying connection unsuccessful, okay? Server may be full. We didn't send that data, why it was unsuccessful, but you could determine that as well. We're just going to say may be full. So there we go. So we have our connection denied packet that we need to create. Okay, so let's go to our message types script, and I'm going to type in connection denied, and I'm simply going to set this to 2, and I'm going to change this one to 3. Okay. These are the actual values that are getting stored in those packets, by the way, 3, 2, 1, 0. Awesome. So we have a way to handle connection denied and a way to handle connection confirmed, which connected is going to be true. Awesome. So that means when our alarm triggers, this code right here will not happen again. So the send connection attempt will not happen again. Awesome. So the next thing we need to do is go back to our server. And when it sends this, so let's say for instance, let me talk to you guys for just a moment. If I can. Okay. So let's say for instance, our client's pinging, okay? It takes 100 milliseconds for our client's packet to arrive at the server. And because of that, we send a message, and let's say for some reason it takes a couple hundred milliseconds for it to receive, the server to receive it. The server has to process it, and it takes a couple hundred milliseconds to get back, or for instance, however long. But within that time, the client had sent another packet. So the packets kind of pass each other, the client's connection attempt and the server's response. Now, in this case, the way we have it right now, the server would actually grab another client ID off the stack and send that one as well to the player. So the player would get 2 inputs, and the client would have taken 2 items off the stack for this one client. So we need to actually store in the server that, hey, we've already sent a message back to this client trying to resolve. So the way we could do that is by storing the IP address of our client, and we have that available in our async event. So we're going to go to our server, and we could simply say received, I didn't stick with my naming conventions here, received IP. And we could simply say this is equal to our async load. And this is an accessor. This is one way you can oh, that's not what I wanted. Access keys or access values using a key and a map. So now we have the received IP. So when we get our connection request, we can then say, this is where we add our new client. So we have client send connection packet confirmed. And then after we send that packet, the next thing we want to do, oh crap, I'm not showing you guys the screen. Sorry, I'm bad at that. I need to not do that. Okay, so what I've done here is I have received IP equals async load IP. And this is in the async networking on the server side server. And this is going to grab the IP of whoever sent us the packet, okay? So which is our client, sends the packet. This is the IP of that client. So we're going to store this in some kind of data structure. So before we send this connection confirmed thing, before we do any of this actually on connection request, we're going to do a simple check. We're going to say if, and this is going to be some data structure that we're going to put together. We're going to say if, let's have, what should this be, a map maybe? Yeah, we can have a mapping of like the client to maybe like the actual client, because we're actually going to create a client instance, this SV client. So we can have a mapping from the IP to the client, and that'll be kind of useful to use. So this is going to be some kind of structure. So what we're going to say is if ds map, I keep doing this, I keep writing these functions before we even create the data structure. So keep this in mind. We're going to go create our data structure for this first. Let's go to our create event, and let's go to our, where do we want this? Up here. We're going to say connected clients equals ds map create. And if you don't know what a map is, it's a simple key value pair. So there's one key that associates with one value, and each key has to be unique. So you can't have duplicate keys in the structure. Thus, you can have a bunch of keys pointing to the same value if you wanted, but you couldn't have multiple duplicate keys pointing to one value, I guess. So yeah, that's basically it. You have a key, which is going to be a string, and a value, which can basically be anything, okay? So we've created a map, and it's empty right now. That's totally fine. That's all we need to do. So let's go to our async networking, and we're going to say if ds map, we're going to check basically if a key doesn't exist. That's what we want to know. And we're going to say exists. And this doesn't actually mean does the map exist. This is bad naming on GML part. This means does a key exist, I believe, right? Let me be sure I'm correct on that. I don't know. I know these things and I question myself. Returns if the given key exists or not in the map specified. Awesome. So what's the key of our map? It's just going to be our IP. Okay, and I think we actually have to turn this to a string. I don't know. It might be a string. Let's assume it's a string for now. It's kind of iffy. I believe it has to be a string, basically. Yeah, it's a string. So we're saying if dsmap exists, and we're giving the ID of the map that we're referencing, which is going to be our connected clients. And the key we're checking for is simply received IP. It's going to be the key. So it looks like this. Let me show you what the data structure looks like. So one key in the data structure would be like 192. Hello. 192.168.0.0 or .1. And this would reference instance create. It would be some kind of a client, basically SV client. So this is going to reference, this is a string actually, this is more accurate. This is going to reference an ID of an instance that we have in our game. Simple as that. Let's do that. So if the key does not exist, then we need to do all this stuff, our connection stuff. And then at the end of this, we're going to add the new, let me maximize this. At the end of this, we're going to add this new client to that map. Okay, so we're just simply going to say ds map put, what is it? Add. Yeah, ds map add. In other languages, it's called put and different stuff, whatever. And then the map we're referencing is connected clients. And the key is simply going to be received IP. And the value that we're going to store is a new instance that we're going to create. So we're going to say instance create layer. And you could actually have a layer specific for clients if you wanted. But we're just going to create it at 0, 0. And I'm going to use the default layer instances. And then the object we're going to be creating is an SV client, which does not have a physical form in our room. By that I mean you can't see it. The actual player that is going to be showing up that we're going to be using for having the server kind of mock up. Not mock. The word simulate our game is going to be the client pawn, and the client is going to own one of the client pawns, and that's what's actually going to be moving that we can see in our room on the server side. So we're going to be creating a new client, and we're actually going to be creating this above here because we need to assign the client some things. Which, is it needed? Yeah, let's do it. So we're going to say var brand new client. We'll just say new client instance equals instance create. And I need to separate this out a bit or something. Okay. That is the client we're going to be adding. That's what our received IP in our map is going to be referencing, is this ID of this new client. So it's going to be our new client instance. And we're also going to assign this new client instance some values. So actually one value, new client instance. We're going to say dot client ID, and we're simply going to save that as the ID we grabbed from, oh, we didn't get it here, did we? Okay, so we actually need to receive this new client ID. So yeah, what we're going to do is say new client ID equals argument 0 here. So we're actually going to pass an argument into the script, okay? So if I go back, see what I did? I set argument 0 to be, or new client ID to be whatever we pass into the script. So here, this script now expects some kind of argument. So instead of doing that in there, we're going to say new, let's say client. I don't want these variables to mix. So yeah, we're going to say var new client ID equals retrieve new client ID, and we're going to pass that in to our script. And it's going to get handled the exact same way. But now we can also assign this to our actual client, which may be kind of redundant now that I think about it, because we have the IP mapping to that instance. So we don't necessarily have to have this, but I believe it's going to come into some use later on. I think when I did my project, I actually did end up using it, but it's not going to hurt anything to have. So that's what we're going to do. Let me go ahead and... This looks dirty to me for some reason. I don't like it. Okay, so let's go over what exactly we're doing. And I'm going to go ahead and, oh, that's self-explanatory. Comment this out. Create a new client instance. Oh my God, all this is self-explanatory, but I feel like I need to comment it. Assign our new client instance to have a client ID of the newly acquired. This is so bad. New client ID. Have a client ID. That's good enough. And then we're adding that new client to our map. That's fine. We'll keep it there. Okay. So we've handled a new connected client. That was a lot to do. Quite a bit. And what do we need to do if the map does exist? Actually, this needs to be doesn't exist, huh? If map exists. Yeah, this needs to be if the key does not exist, then we do all this because we're adding the key. If it does exist already, then we're just going to ignore that packet, okay? Easy. So we did our connection request. Awesome. So now we've sending back to the packet. I'm trying to figure out exactly where we are at this point. Let's see. Alrighty. So next, connection handler. Let's see if we flushed out everything inside of our client. Okay, so we have our create event. Send connection attempt, fine. That's what we did. Stop moving me around here. We have client connection attempt. Gonna keep sending it until we receive a response. And then blah, blah, blah. Well, what happens if we don't receive a response for a long time? Maybe we have a max amount of connection attempts, okay? So what we could do is we could give ourselves a maximum amount of connection attempts, which actually we aren't going to do that now. I've spent enough time. We haven't even ran the crap yet. So let's receive that connection confirmed thing and show a message saying that we received it from our player. And we're simply going to do that with a show message. And this is on the client side. We are now connected. Okay, so now we should receive a message back from the server saying that we're connected. So let's see what happens. So let me go ahead and run this, and I got to open up my second instance of the game. Where are you at? Where are you at? Where are you at? Tutorial series. Okay. Okay, it just reloaded everything, so I'm gonna build this. Okay. Where are you guys? Hello? Where's my game? Did it work? Did I get an error? I might have gotten an error. Async, networking, line 20, unknown function or script. Oh, retrieve new client. What? Retrieve new client ID. SV retrieve new client ID. Okay, so I misspelled the scripts. I need to actually turn on highlighting. You see how it's not highlighted? It's not good. Okay, let's try running this one more time. Bad variable and buffer seek on connection connection handler. Connection on handler stalls that bad variable and buffer seek. Where are we at? Buffer seek. Send buffer. On connection handler. That's what you're talking about. So buffer seek received buffer. Oh, good catch. So we add a bad variable here. Why did I do that? Received buffer. Okay, so yeah, received buffer. I had an underscore in it. I don't remember doing that. It's odd. Okay, good catch. Let's see what happens. Please run, please run. This is what happens when you go too long without running your game. Need to open up my second instance and need to build this one. Let it run. Let's see what happens. Okay. So we're gonna hit server to create our server and start listening for data. Then we're gonna hit client, and we got a new connection attempt, but we didn't actually receive something back, and that's not good. So let's do one more thing. Let's see. Bum, bum, bum. I actually, now that I think about it, we should have did the messaging system in the client as well, but I'll bring that out another time. Okay, so let's go through the logic. What happens? Our server's obviously getting the connection because we're getting this connection request. And now we're saying if the map does not exist, basically if the key doesn't exist, which is going to be the received IP, then we're going to do this stuff. Okay, and that's when it does the new connection attempt. Okay, that worked just fine because we got that message at the top left. And then we have new client ID equals retrieve new client ID, send packet connection confirmed with our new client ID. And then new client instance. So I actually want to, let's actually print out one more message to our thing. I will do that in a second. So we have new client ID, DS map add. Okay, so let's go to our connection handler on our client side and make sure we're receiving the packet correctly. Okay, so we're seeking the buffer. We're receiving the buffer, seeking the buffer, the first position in the buffer, and then we are getting the received packet type. Okay, I want to go ahead and when this is triggered, I want to show a message. And we're going to say we did receive. We never sent the message. I know exactly why. If we go back to our client or our server side on the send packet connection confirmed, we built our buffers. We never sent our buffers. So we're simply going to do buffer send. Wait, what is it? Buffer UDP. What is the network? Sorry, network send buffer. No, send UDP. Okay, send UDP raw. I forgot that thing like 20 times. Awesome. And then we have to find a socket to send it with. And if we remember, our socket is in our SV server create event. Okay, so we have a network socket that we created, and it's simply called socket. So from our connection confirm script, we're going to use that socket. Remember, it's like basically like an envelope that we're using, but we aren't sending the actual envelope. We're sending the data in the envelope. It's kind of odd. Okay, and then we got to give a URL to send to, which is actually going to be our client's IP address. So we have our new client ID, you can see here, and we can actually now, let's go back. Let me make sure I set this up right. Where's our server? I don't like going back and forth right here. Okay, so we have our async networking. Let me get rid of all this other stuff. Create. Async networking. So we have our IP from the received IP, so we could simply use that, okay? So we're going to say received IP, that's where we're sending this to. And then we're going to send it to a port, and we can actually get the received port by using received port as a new variable. I copy and pasted that top one. And it's going to be the value called port, which is going to be the port of the user that sent us this packet. So that's the port we're going to send it to. So we're going to say received port. And we're going to send our data, which is our buffer. We're going to use our send buffer. And we're going to give the size of the data we're sending, which we can just simply use buffer get size. And we can get the size of our send buffer. And as you can see, we can actually cut this out and we can move this to the bottom here. And we don't have to copy and paste it for the if and the else. Okay. Now we are getting an error. What am I missing? Expected. Oh, buffer right. Did I accidentally get rid of that? There we go. Okay, so we're sending a UDP packet to our client at its IP and its port. And we're sending the data that's inside of the buffer we created and wrote to. And we're getting the size of that buffer we created and wrote to. Okay, so this should now send our packet. So let's see what happens. So I'm going to hit play. Let's grab our second instance of the application. I'm going to hit play. I'm going to go ahead and create my server on this one. And our client one. There we go. So we sent our connection attempt. Our server sent us a packet back saying, hey, you got your connection attempt. We can actually get our client ID at this point because when we get a successful connection, remember that packet contains our client ID. So let's see that in action. Let's go to our connection handler for our client side. And when we are now connected, since we know it's a connection confirmed type packet, we know that it has one extra piece of data available for us to read. So we're simply going to say, what is it? We're going to say var new my client ID equals. Actually, let's store this as an instance variable for our connection handler. So let's go to the create event and let's keep the client ID inside of this, okay? So we're gonna say client ID, we're gonna say equals. Basically when it starts out, we'll say it equals -1. Seems fair, okay? And we can say, now here we can say client ID equals, and we simply read the next byte inside of our buffer. Remember, we read the first one for our message type, and if we go back and we see how we built this message, when there is an available client position, our first byte is the message type, and our second byte is the new client ID. So that's what we're going to read out, is that new client ID. So let's go back to the connection handler, and this is in the async networking event once again. And the client ID simply equals buffer read, and we're going to read from our received buffer, and we expect it to be a type buffer unsigned 8-bit integer. Awesome. And now we can display a message. Let's actually put this before the message, sorry. We can actually display a message showing our new client ID. All right, connected assigned ID plus string client ID. And let's add something a little even more at the end of it. From server. Let's say by server. It's more better language. By server. Okay. And I think that's going to be it. We are now connected. Assigned ID. So we should get that connected ID. Let's go ahead and let me load up my instances of the game. We can actually, let me open up one more instance of the game. Let's see how that works. So if I go here. So I'm going to have 2 clients, 1 server. I'm going to go ahead and start my server. Another way you could do this is by building an exe and then running your exe as many times as you want. Is this going to break for me? Come on, don't break on me, Game Maker. You got this. Okay. Play. Let's build this bad boy. Waiting. Computer's dying. Okay. So we have our server. Let's connect 2 clients now and see what happens. So let's connect our first client. And you can see we are now connected, assigned ID 1 by server. Now, I believe it should be 0, so I think we initialized our stack incorrectly, and we'll go over that in a moment. So we are now connected, assigned ID 1 by server. Awesome. So now we have a second client. Now when this one connects, it should be assigned ID 2, and we should get a new connection attempt up here. So let's hit client, and we did not get that. That's interesting. Why? Oh, I know exactly why. Why did this not happen to me before? So what's happening is our DS map, remember? It's not allowing us to connect twice from the same, IP address. So that's one issue I didn't think about in this connection. It's working how we told it to work. Where is my stuff? Get out of here, guys. Get these projects out of here. Okay, so if we go to our server, it's actually not allowing our IP address to be connected twice. Thus this thing, okay? So let's go ahead and get rid of this just for now. So I'm going to comment this out. We're going to try this one more time. DS map add. Yep, I think that's all we need to do. Play. Then let me open up a third instance. So let's make 1 server. This is exactly what we told it to do because we don't want the same IP to be able to connect twice, obviously. but I untold it or I didn't untell it. I ignored the fact. So hopefully this will work. And if I hit client, we get the connection, assigned ID 1. Now let's just get the second connection. There we go. So we got 2 clients connected to the server now. We are now connected, assigned ID 2 by server. So this is our second client, and obviously it's assigned ID 2. Now, that worked. We're not handling disconnections at the moment, and we're gonna go over that in the next video, but let's go ahead and fix our stack. So if I go to my, where we initialize our stack in our server, we need to actually do as I is greater than -1, okay? Because it actually cancels at 0 and it never actually gets to 0. It'll stop when it gets to 0 instead of including 0. Basically, I was excluding the value 0. Alrighty, so that'll work. So I'm gonna hit play and just try one client now. And we should get 0 as the connected ID. So let's hit create a server. Awesome. And let's connect with the client. There you go. So now we're assigned ID 0 by the server. So now we have 16 positions in our room from 0 to 1 that our server can handle. And I think I'm going to do a small video next time where we're going to actually set up the messaging system and the client as well as the server, so we can actually see our stats up here too, and we can start handling chat messages. But now we have connected clients, and as you see, we don't actually have spawned in players, and we're actually going to handle spawn systems and things like that. So in the next video, we're going to handle disconnecting. We're going to handle the heartbeat that I was talking about, and then we're going to start handling spawning the players in, or having spawns on the server side. So we're actually going to handle seeing the clients on the server side given positions, and the client will just see themselves for now. Okay, so I hope you guys enjoyed this video. I'm going to give 5 minutes for questions and answers, and then I'm going to head off on this one. Yep. So 5 minutes. During this 5 minutes, I'm going to kind of go over what we did one more time. So if someone wants a summary, they can get it, and you're free to ask questions at this point too. Okay, so today what we did is we created a server, or we didn't create a server, server was created, but on our server side, we handled connections. So we have a new map called the connected clients, which is a key value pair, where our key is going to be our IP, and the value is svclients.id. It's an ID of one of our clients. Okay, and this is going to be a useful map. So anytime that we receive a message from a user, we already have their IP available, and it's really easy for us to find which client instance is going to be associated with that IP. And that client instance is going to control basically the graphics and the simulation on the screen. The second thing we did is set up our client IDs with a stack, and we pushed values onto the stack, and these are going to be easy when we handle disconnections to add back those values back on our stack, and easy for us to tell when we're out of room in our server. Okay. The next thing we did is create a connection confirmation, because since we are using UDP, we don't have a sense of connection unless we create it. So when the client sends a message to the server, the client doesn't know if the server received our message. So the client's going to keep sending messages at a standard interval that we assign. One step further that we could go is to give it a maximum attempts to be able to receive a message, or a maximum wait time. So it's going to keep sending a packet. We could say, hey, after 20 seconds of sending packets, let's go ahead and, let's XNA this. Connection just unsuccessful. You could do that on the client side, but we're not handling it at the moment, so it'll sit there and ping packets to the server forever if it wanted. But when the server does receive one of those packets that are sent from the client, a connection request packet, then it handles it. So what it does is if we go to the server and go to where we receive messages here. This is not where we receive messages. This is where we receive messages. So when we receive a packet from the player, we get the packet type. If the packet is, wait, is this our client? Come on. This is our server. Sorry, I was on the client side. I clicked it, I swear. So we have a message type. that we receive as the first byte in that packet, which this is what a byte looks like, remember? So this is the first byte in the packet. The packet could contain multiple strings of bytes, just like this. Okay. And if it does contain multiple, then that's how we can read multiple items out of it. But this specific packet contains 1 byte. And it's a connection request, okay? When we receive that connection request, we log the message at the top. We retrieve a new client ID from our stack, which simply pulls an item off the stack if available. And if the item's not available, it returns -1, okay? And we actually didn't handle the returning -1, did we? Send packet. Oh yeah, we did. We did handle it. Wow, I'm everywhere. So after we get that client ID, we say, hey, if we got -1 for our client ID, we obviously know the server's full, okay? So we construct a message to send back to the player, which this says if it's not equal to -1, it's doing this. If it is equal to -1, it does this. So this is where we construct a message to send back to the client. And we simply send them a message with a single byte that tells them that their connection was denied. Now, had we received a valid client ID, we know position or room is available in our server for a new player. And given that, we construct a new message that has a connection confirmed type, which this is just the value 1, literally the value integer 1. That's good. And then we also add our client ID into that packet. So when the client receives it, it knows its own client ID, which may or may not be useful. It can use client IDs to control all the instances in the room, and that's probably what we're going to be using it for. Because we don't want to send the player everyone else's IP address. That doesn't seem safe, and it's kind of inefficient to send a long string. Instead, we could just send 8 bits of information about the clients that are interacting, okay? So each client basically on the client side is going to have its own client ID. Each instance in the room is going to have its own client ID. Okay, so we write that and then we send our packet to our client, and then back at our client side, oops, sorry, I'm going to close this. Client side on our connection handler, we receive that connection confirmed packet. And after we receive that, we know, hey, there's going to be a client ID in this packet. So we go ahead and read that client ID out, which we know is going to be an 8-bit unsigned integer. And we assign that to ourselves. So yeah, client ID, we're assigning it to ourselves. And we show a message that we are connected, and then we set connected to true. By setting connected to true, it stops our polling and our alarm. Basically, our alarm's not going to get reset, and we're not going to send another connection attempt, okay? So remember, this is pinging packets to the server. It's just sending packets to the server until it gets a response. However so often is specified by this connect attempt wait time, okay? So you could also, once again, handle connection attempt amounts here. So you could say if each time this happens, you could increment connection attempts amounts, and you could say if connection attempt amount is greater than max attempts, then go ahead and stop doing it. Return to our lobby or whatever, okay? So that's everything that we did today, and I hope that makes some sense. And not sure why so many people hard code the enum values. Sort of defeats the feature. What do you mean hard code the enum values? Am I doing something wrong? Hard code the enum values. Message type. Oh, you mean doing the equal sign. I'm literally only doing the equal sign to show people exactly what's getting inserted in the packet. That's the only reason. Another reason is that's not necessarily the only reason to use enums. I don't know if GameMaker guarantees it, but many languages don't guarantee what order these are going to be in. So this might not be 0 every time. Some languages do that. But yeah, I know what you mean. Yeah, I'm just setting it just for visuals on the tutorial. And it doesn't defeat the purpose of them. I think the main purpose of enums is so you could see exactly what it's referencing, right? So, for example, I could do message type dot, and this gives me a complete list of message types, okay? And they don't belong to any one instance or object in GameMaker, and they don't have to be initialized at any certain point. Like, this script is not in any of my instances, okay? So, yeah. that's one nice thing. Another way to do it is using macros. You could do that as well. But yeah, it's literally just, the reason I'm doing it mostly is for the viewers, so they know exactly that this is the exact value being placed inside the packet. So game instance with the server will have the client objects, and the client games will have the representation of that object. So the game instance, so the way this works, the way this architecture, client server architecture works, which is used by most first-person shooters, real-time, fast-paced games where you don't want cheating and different things, is the server runs the game. The server has the last say in everything, okay? So the server, it receives client connections. It creates a client, which the client in this case is not going to be a visible object in the room. It's just holding some information about a client, basically. And that client owns a pawn. So when that client gets spawned, the server spawns a pawn, right? And it's going to pick a position for this pawn, and then it's going to send the position of this pawn to all the clients, okay? Or all the clients that need the position of the pawn. And they're going to update their game. Basically, they have they have pawns for all the other clients, and then a pawn for themselves in their own game. And they're going to update the position based on the packet that they receive, okay? But when you make a movement, for example, you press arrow keys as a client anyway. So you're playing the game and you press the up key. Your client actually sends a request to the server to move you, okay? So you don't actually move instantly, right? So the client processes this packet, runs the movement in the simulation in its own game environment. It's going to run that movement for that instance of client. And if there's not a collision, whatever, it updates that position, and then it sends the updated position to all the clients, okay? And including the client that sent it. So the client that sent it gets its response back and say, hey, it's a valid move. So it actually updates its own position finally after the server does the actual physics simulation. And obviously there's lag in that, and we're going to be going over what is popularly called client-side prediction, where basically the client tries to run the same physics code as the server and predict where it thinks the server is going to place it. And that comes with some other problems that we're going to have to face, such as server reconciliation, which is what happens when the server and the client's positions and they don't think what they think is supposed to be happening isn't matching up, which again, the server has the final say, but there's ways to kind of work it out so it happens smoothly and it's not awful. So I hope that makes some sense. Yes, the server runs a simulation of all the clients, and it processes all the input requests, and the clients don't have any say over where they are. They just make kind of an assumption of where they're going to be by the time the client responds. Or the server responds, sorry. I hope that cleared it up a bit. And TMC, yeah. I know you can insert in the middle of this and stuff, but as I said, I'm just trying to show users what is actually being put in. Because newer users that haven't used enums as much, this isn't as obvious when you type a packet and you put this value in a packet. Oh, sorry, I guess it would be this. This isn't as obvious when you type this into a packet. They don't understand necessarily. Or they may not. I'm not saying they never understand. But yeah, that's why I'm keeping this for this tutorial. All right, let me get rid of these. Alrighty, so I can close this down. We made some progress today. Wow, an hour and a half for that video. Whew. But yeah, the thing I like most about this is the drop down. I know it seems silly, but well, show me. It won't show me from in here. But yeah, I like the drop down. But let me show you guys something. No, I gotta end this video. I'll show you. I'm gonna do a small video on some cool tricks and stuff pretty soon. I had a thought of it on the way home today. But all right, if you guys don't have any questions, I'll give it one more minute and then I'm gonna head out. I have to work on my save system for stuff, so I'm gonna go ahead and actually pull that in from Git. Save system. Where's my sync? Change this sync. All right. Okay. You can use macros for more than constants. You can actually check it out, watch. Oh. Is that how you spell colon? I don't think that's right. You can actually do this with macros. I guess probably won't understand that, but yeah. So it'll actually give you compile errors, but I think it's actually still going to compile. Or it's going to give you, yeah. So wait, server. It actually still works. So you can actually use these for anything. It works just like if you're doing it in C++ or C. Yeah, you can actually, because how macros work is actually when the game compiles, it goes through your code and it does exactly this. So it's giving me an error because it's doing real-time evaluation of this, but when you compile this, it gets this macro. That's why you don't use equal signs on macros or anything. So it gets this macro, and it says, okay, I'm going to find everywhere that this is used, and it actually replaces it with what it is. So your compiled code actually resembles more like this, okay? These actually go away. These macros go away, and the values are actually replaced with a symbol or whatever, which you don't actually have to only use symbols. You can do this with anything. You could write a full function. You could say, let's say, move to mouse. You could literally, or I guess you'd do like dir to mouse, and you could literally write point direction x y mouse x mouse y. There you go. You literally have, you can now say my direction equals dir to mouse, and that'll actually use that function for you. So yeah, you can use it for anything. Okay. So the client on the server instance does the collision checks and whatnot, and prediction would be the client side running the same code-ish code. Then we'll change these if the server gives different data back. Correct, that's correct. Just trying to wrap my head around the architecture, put the code. The client basically only draws the position of the objects. Exactly. That's exactly correct. And as I said, when you do client-side prediction, you are actually going to run physics code. The days before Quake, they did not run the physics code client-side. But they mostly did LAN and stuff then, right? So it wasn't as huge of an issue. But when they started developing Quake and they were getting over the internet, they ran into that problem where John Carmack actually was kind of disappointed that he had to run the client code on the client side as well to do prediction, because it's not quite as elegant as just running it on the server, and then the client is just basically a dumb terminal. It's just updating images on the screen. So yeah, run the same code on the client side, and then there becomes issues with that because of the delay, and then you have to do server reconciliation. So if you're playing a first-person shooter and you warp back through a doorway that you just walked through, what's happening is you're actually playing back because you and the server disagree on your location. The server's telling you, hey, you're not supposed to be in that room, so it drags you back outside. So that's why it's super annoying to play sometimes, but that's what happens, is the server's telling you where you need to be, and you are having to listen to the server. Curious to see how the lerp stuff works, like how all the frames get data gets saved and lerped to. Okay, so every step you're gonna have a new position, or not every step, but when you receive data in the network event, remember, this network event can happen multiple times per step. So if you're only running 30 steps a second, your networking event can still happen 100 times in that second. This can, because it's asynchronous. It's not with the rest of the game. It's running on a separate thread, basically. So what you can actually do is when you receive a new position update for a client, which there's a lot of ways to do this. I'm trying to think of the best way to show right now. I still have to decide that, because the way I did it was a bit too complicated to do in tutorials, and it's not necessarily the best way either, but you can either try to package up basically multiple clients into one packet, or send packets for all the different clients. And there's a kind of trade-off. You don't want to send too many packets, but at the same time, you don't want to send packets that are too large, because if data gets lost, you lose a lot of data. So what we can do is actually, when we receive that position update, we move the players on the screen. And it's really easy. You could just set your target X for that client to the new position, and then literally just use the lerp function to lerp between its current X and the new target X, okay? Anyway, I'm going to have to jump off here. I'll chat with you guys in chat, but I have to take a phone call. So thank you guys for watching, and I'll see you guys next time.